Here in video 2, we have 3 examples using those rules of logic. And so from these 3 examples, we're going to find a valid conclusion that we can make from the true premises, and then we'll tell which rule of logic the argument illustrates, or which rule of logic we used. So example number 1, if Amy gets at least a 90 on the final, then she gets an A for the course. Well, what's true? Amy got a 94 on the final. Therefore, she gets an A for the course. Now, what rule of logic did I use for that? Well, I'm going to go back to my P's and Q's and think, how did I get to that? So, if Amy gets at least a 90 in the final, that kind of is like a P. So, because I noticed right away, I have this if-then statement. And then I think, okay, if Amy gets at least 90 in the final, then she gets an A for the course. So, I see a if P, then Q. Well, my next statement is Amy got a 94 in the final. So that means P is true. And then from that, I can draw a conclusion that, therefore, Q. And that is a direct argument. You can think about it that we're directly following the arrow. If P is true, then Q is true. P is true, then Q is true. Example number 2, cows eat meat or they are herbivores. I notice right away this or, so I think, okay, it must be one or the other. So cows do not eat meat, therefore, they are herbivores. Once again, I can break it up and say, okay, cows eat meat, or they are herbivores. So that's like saying P or Q. Well, not P, because cows don't eat meat. So therefore, it must be Q, since P is not. And because, once again, since we use that or, it must be the or rule. In the third example, if a number ends in 0, then it is divisible by 10. And if a number is divisible by 10, then it is divisible by 5. So conclusion, jumping that middle step, because we would know it's true from the first if it was, from the first part. So if a number ends in 0, then it is divisible by 5. So this is like our P. If a number ends in 0, then it is divisible by 10. Okay, and then the next part's the same as Q. It's another Q. If a number is divisible by 10, then it is divisible by R. So that's like or divisible by 5. So that's like our R. And so what we would say is we have this P of Q then, type of statement again, and then Q, then R. Therefore, we can just cut right to the chase and say, well, P, then R. And we know that when we use this kind of logic of if P then Q, if Q then R, if P then R, we call that the chain rule. Because it's kind of like you have multiple links in the statements that can make you jump that step and logically conclude that therefore P must, if P is true, then R is true.